Okay, good morning. So we'll continue with our discussion of the next numerical method in our lineup. I wanted to make a couple of announcements before I start today. One is if you went to Canvas this morning or last night, I reposted this file with links to with links to my course materials from last two times that I taught this course, fall 23 and fall 19. I'm working through my fall 18 stuff, so you would have one more folder, more examples and exams to work on. And also after each lecture, when I get the recording, I upload it to YouTube and I post the link. So this syllabus file is going to be updated after every lecture and reposted. So the link is right there for you to use. This is a tough class in the sense you need to do a lot of practice, and I'm doing my best to give you more and more examples. There are not heavy concepts, but a lot of practice. Okay. All right. With that out of the way, I will be trying to do examples from the first homework as we do discussions today. Okay. And here is where we left off last time. Okay. So we did the graphical method. First, we did the solution process where we plotted the function between -5 and +5 with a step length of 0.1. We identified -1.4 is a possible root. And then we did the same exercise again with a higher resolution or a smaller or a finer step size, 0.01. And we got the solution with three significant figures, -1.41. Okay. And if you did the plotting, here are the two functions. This curve right here, the bell, the inverted bell, is your parabola 1 minus x squared. And this wavy curve is your sine x. Okay. And graphical method is literally looking at the graph and seeing where the intersection takes place. So you see there is a root here between 0 and -2, which we identified as -1.41. And between 0 and +2, which we identified as something like 0.65, if I remember correctly. Until here, are you with the story? It makes sense? Okay. All right. What I mentioned also is graphical method is very inefficient. You have to do plotting, you have to do inspection, you have to handle a lot of numbers. It's very inefficient as a method. What we want is something that is more systematic, something that can be programmed and automated so that you could just put in your function and expect a solution, which is what we are going to study today. It's called bisection method. And bisection method can be understood very easily, just starting off or picking up where graphical method leads you. Now, don't write, look up, answer these questions for me. There is a root between 0 and -2, correct? Correct? So if I write my function to be solved, if I write it as f of x equal to 1 minus x squared minus sine x. Remember, I was trying to solve 1 minus x squared equal to sine x. Let me define f of x as this, and then I want to solve f of x equal to 0. Same thing, right? If I say f of x equal to 0, just consider what is f of 0. Just consider what is f of 0 and consider what is f of -2. Okay. So what I'm going to do now is take the function and calculate. I thought I'll use gloves to protect myself from the markers, but whatever. So I'll define f of x equal to 1 minus x squared minus sine of x. All I need to do is calculate LHS minus RHS. Okay. This is for illustration. Just wait. I'll give you time to catch up. Okay. I'll tell you when you need to stop and listen. This is one of those times. So LHS minus RHS. So I'm going to populate that. Okay. So I have f of x calculated here and instead of plotting the left side and right side separately, I'm going to plot f of x versus x. Okay. So let's go back to our graph, duplicate it. Okay, duplicate it. I don't want this wavy curve. And for the bell curve, I'm going to replace the data as x value, and y value I need to replace it with this. All right. I think I also need to fix something. No, it's okay. All right. So now, is this correct? Did I do this right? That doesn't look right. Okay. Maybe I'll just make my point on the whiteboard. So consider this situation. You have a function f of x equal to 0. Okay. If you are considering the function wherever it meets the axis, and this is the point where f of x is equal to 0, okay, how would you think about an interval a comma b, okay, a comma b, which are both on the same side of the root, and then another situation where you consider a and b to contain the root. Here ab contains the root, or the root lies between a and b. Here ab are on the same side of the root. How will you say this statement mathematically? How will you say? So if you consider this value of the function here, what would that be? F evaluated at A, right? And this is F evaluated at B. This is also F evaluated at A in the other scenario, and F evaluated at B. Can you see something here, or do you want me to give one more clue? If A and B contain the root, then what is the product f of A times f of B? That product should be negative, because the function f, the value f of B is on one side of 0, either negative or positive. F of A is on the other side of it, by definition opposite side. So the product of these two will be negative. You can also write the statement, if A and B contain the root, this implies f of A, f of B is less than 0. If this is less than 0, that also implies A and B contain the root, or the range A and B contain the root. If it were not obvious when I made the first question, but after I say this, does it look obvious to you? Yes? Yes? Okay. The contrary is also true. If f of A multiplied by f of B is positive, that implies AB does not contain the root. Now I'll let you write this up. Yeah.
When you mean contain the root, are you talking about the initial equation, or I guess I'm kind of confused about just the.
So I'm okay. This is one example. In general, let's say I'm thinking of a function, and I want to find out the zeros of that function, or in other words, the values of x which will make that function zero. Okay. So if I ask you what is the zeros of the function, if f of x happens to be 1 minus x squared, you will say that is x equal to plus minus 1. You didn't need any special technique for that, but for such nonlinear functions, we need a technique. And any function, if you graph it, it's going to cross zero, which means it has a root. It may never cross zero, which means it doesn't have a real root. We are seeking real roots of an arbitrary function. Okay, so what I'm saying is, let's get to an example. Okay, let's write this as f of x equal to 1 minus x squared minus sine x. Now you already did the graphical method. You know that there are two roots for this equation, and you know exactly, or you know approximately where they are. That is, you know that x equal to minus 1.41 and 0.65 are roots which we got from graphical method. One of the problems we identified with the graphical method is that if you want more precision, you need to handle a huge stack of numbers. We can just go back and say, forget even the second decimal point, minus 1.4 and 0.6 are also roots of this equation, roughly speaking, with a very low precision. What does that mean? We can say minus 2 to 0 contains a root. So does 0 to 2. You can check this. If minus 2 to 0 contains the root, what is f of minus 2 multiplied by f of 0? You check this. F of minus 2, you can punch in the numbers. I can look it up and say f of minus 2 happens to be minus 2.0907. Minus 2.0907. And f of 0 is 1. 1 minus 0 squared minus sine 0. So this is 1. Of course, this is negative, which implies, and also the other way, minus 2 to 0 contains a root, not the root, a root, because there are more than one roots. Are we all together? No one's feeling lost? Because if you are, you should say, you should kind of slow me down for me to, try something else. You can also check the other range, 0 to 2. F of 0 multiplied by f of 2 is 1 multiplied by, what is f of 2? Minus 3.0903. Minus 3.0903, which is of course negative. So this also implies 0 to 2 contains a root. All right, good. So now, let's say you know minus 2 to 0 contains a root. How do we now get precise? How do we we have identified the range or the ballpark. Now, how do we hone in on the final answer? To what degree of precision should we go for? How many significant figures should we go for? Say something. There is like no correct answer to this question. 2, 3. In reality, the number of significant figures is not dictated by your choice. It's dictated by the quality of data you're handling. I was taking my child's temperature. The temperature is read to 1 decimal point, 100.1. That's 4 significant figures I can get. If I wanted 3 more significant figures, like if I wanted 100.14, I'll have to pay a lot more for a sensor that can give you that precision. So it's not that you can just pick it by yourself. It's either provided to you in the context or in the exam. I'll tell you, get me 4 significant figures over there. Okay. So it's not etched on stone. That's what I'm saying. All right. -2 to 0 contains the root. Okay. Now we are going to draw a table and do a hand calculation, which you kind of later will implement on Excel. Okay. First, let's do it by hand. All right. I'm going to redraw my figure, or actually maybe modify this figure. So here is A, which is -2, and here is B, which is 0. Okay. And we know this is the root. We'll call it x0 to be determined. We don't know. We'll have to figure it out. Okay. So we'll write f of A, f of B. Okay. I'm sorry. I should start with A and B. A, B, f of A, f of B, and then we are going to say nu A, nu B. I'll tell you why nu A, nu B. Okay. What is A? -2, B 0. F of A is -2.0907. Where am I getting that from? F of x equal to 1 minus x squared minus sin x. If you want, I'll give you 30 seconds to take your calculator, punch in -2, and convince yourself where this comes from. You're okay? Okay. F of B is 1. Okay. So actually, I should have done this. I should write f of A times f of B, which happens to be, you can do the product, but the point is it's negative. Okay, f of A, f of B product is negative, which proves that you are still containing the root. Now, let's say x naught equal to A plus B over 2. That is, I'm just arbitrarily going to take the midpoint of A and B, which may fall here, which may fall here, but I'm just going to say, let's consider the midpoint of A and B. Let's say it falls here. So this is x naught is A plus B over 2. What is x naught in that case? X naught is A plus B over 2, which is -1. -2 plus 0 divided by 2, -1. Are we okay? Now, what I want you to check is, check what is f of x naught. Compute this function with argument -1. What will that be? I'll wait for you to tell me. You can use Excel. I mean, better use your calculator because that's what you'll do in the quiz. Anyone can do faster than this? Come on. What is f of minus 1? 0.017445. Let's say 4. Let's say we'll keep it at 4 decimal points. Are you sure? Because I'm getting something else. Did you check the degree and radian? This x has to be in radians. When I say x, sorry? Yep, that's what I'm getting. 0.8415. 4 decimal points. We'll keep that as like a standard between us. So 0.8415 is the value of the function over here. 0.8415. Remember, this was 1 and this is minus 2.0907. Once you have written this down, drop your pencil and tell me now, where is the root lying? We still haven't found it, but we are kind of squeezing the range. It was previously between minus 2 to 0. Now where is it?
Between the -2 and
Well, remember, this is the y value, not the x value. What you are trying to say is it's between minus 2 and minus 1. That's what you're trying to say. Do others agree with that? From minus 2 to 0, we have now narrowed the range between minus 2 to minus 1. Minus 2 to minus 1 now contains the root. We just don't know where exactly it is, but we are getting there. Okay. So then the next thing you need to check is f of a times f of x naught. If you consider those two, that would be negative. Okay. And then f of b times f of x naught, that would be 0.84 multiplied by 1. Positive number, product is 0. Okay. The product is positive, meaning greater than 0. To redraw the figure here. Minus 2, so minus 2, minus 2.0907, 0, 1. This is the root, the mystical root which we are seeking. And then here is minus 2 plus 0 divided by 2. And this value is 0.8415. This is the picture so far. Okay. Pause, listen for a second, please. You did this, you figured out that this product is negative, this product is positive. What is the inference from here? The inference is the root is contained between a and x naught. Contains the root b to x naught or x naught to b is no longer relevant. You have brought in the range from here to here, minus 2 to 0. You have squeezed it to minus 2 to minus 1. Okay. So our new A, we'll call it A star, is simply the old A, and the new B, which is B star, is X naught. So if this idea clicks with you, in no time you can put this on Excel and turn this into a spreadsheet. Okay? So new A and new B you have identified. New A is just old A minus 2. nu b is x naught, which is minus 1. F of A still remains the same, 0.907. F of B is the whatever is the old f of x naught, which is 0.8415. Now make the same determination. Is their product negative? Yes, good. It has to be because that's how we got it. Am I going too fast? That a yes? No? Because this stuff, once you figure it out, it's so easy to do the next step. Okay, so stop me if you need. All right. X naught is a plus b by 2 minus 2 plus minus 1 divided by 2, which is minus 1.5. F of x naught. Compute what is f of minus 1.5. Correct. 2525. Negative 0.2525. Okay. Now you do the same decision making. What is f of a times f of x naught? This multiplied by this. Negative and negative multiplied gets you a positive number, which implies a to x naught is no longer relevant. So this means if you have minus 1.5 here, okay, minus 1.5 here, this range is no longer relevant. Just like this range became irrelevant in the previous step. F of b times f of x naught. F of b is this. F of x naught is this. Positive, negative. Their product is also negative, which implies b to x naught contains the root. You would have obviously figured out that when I refer to a and x naught, I am talking about this iteration and not previous iterations. For this iterations, a represents minus 2, b represents minus 1. Previous iteration, it was different, and so on. Now, do it yourself. Do one iteration yourself and then look up. Try this yourself. Now you know how to figure out the new A and new B. Do the next iteration, go through the steps, and we'll meet there. Don't look up. If something is not clear, feel free to ask me also. 6, 5. Three times UA star is not this 1.5 and UV star is 780, which is star. Did you try and were you able to try? Tell me what differently.
That's what I had.
Kind of. What is kind of?
I went back to the video. Just about.
No, you can ask me now. I'm asking you, are you getting this new A and new B to be these?
Yeah, but
Still not very confident. Okay. We'll just,
I look back at the video.
that's okay. You can look back, but we'll try to do one more iteration together.
Yeah.
Others? Others, were you able to do this iteration by yourself? Yes, no? Getting there, still working on it. To give you a couple more minutes, okay, and then we'll try to do one more iteration together. Partner, are you able to get this? Others who have got this, I need to know in what proportion we are going. Like, if you've had this answer, tell me. If you have not, tell me. Good. Good. Why? Good. No? Working on it?
Yeah.
Okay. Shall we do this together? Would you like me to? Right? Okay, let's start over. I'm going to erase all this. You don't have to write now. Please listen. Sorry, what's your name? Yeah, please listen. Okay. All right. So are we all here? Minus 1.5 and minus 1 from the previous iteration. Very simple next step. Compute the value of the functions. What is f of minus 1.5? What is f of minus 1? You know that minus 1.5, you can just copy that number. This number comes here. Okay, don't write now. Listen. You. Just listen. Later you can talk. Okay. And then what is f of minus 1? You have to keep remembering what your function is. which is f of x equal to 1 minus x squared minus sine x. So punch in minus 1 in here and you will get 0.8415. Okay. This is a basically if statement. Is the product positive or negative? That's the question, right? What is the product of these two? Negative. That's it. No need to compute it. Just put the product negative. So then you compute the midpoint of this. What is the midpoint of 1.5 and 1? 1.25, right? Minus 1.25. Simple. Midpoint. That's why this method is called bisection method. Okay? Midpoint. And then compute the value of the function for minus 1.25. If you want to actually do it now. Compute f of minus 1.25 with me. You get minus 0.3865. 3865. Thank you. Good. Good. 3865. Okay. Now it's another two more judgments. What is the product of f of a, which is here, and f of x naught, which is here? This is like asking, I have a to b, a is here, b is here, and x naught has been identified in the middle. Just asking what is the product? Is this, are they both on the same side or on opposite sides? That's all we are asking. So what is the product? Is it positive or negative? Is the product of these two numbers positive or negative? Positive. Positive, right? So you have just said the left point has now to be shifted to the midpoint, and the right point, if you take this number and this number, is their product positive or negative? Negative, right? So that you have a range, you have the midpoint, the left becomes the center, or the center becomes the left, and then you have the right standing where it is. Sort of describes America, doesn't it? I don't want to get into politics, but so you have the new A. The new A has to be the midpoint, and the old B is still the new B. So you can take these three numbers. Wait, still goofing up again. This is f of this multiplied by this is positive. This multiplied by this is negative. So I have minus 1.5 replaced with minus 1.25. That doesn't make sense. What did I go for? Oh, minus 0.865 or plus point? You should have fixed me. You could be wrong. I could be wrong too. So you should say you should at least say I'm not getting this. Be factual. You don't have to make judgments. Just say I didn't get that. Okay. So then this changes the whole thing, because now the product of this number and this number is negative, and the product of 0.84 and 0.38 is positive, which totally flips the script, and you get A star is still A, but B star is now X naught. Did this iteration click with you? So A star now becomes A, which is like writing minus 1.5, and B star is minus 1.25. When I do this, I constantly know if I'm making a mistake. I almost know the answer before starting. How?
Not, if it's not negative, then you know you're not gonna find the root.
Because you already know where the root is. You did the graphical method, right? Graphical method by itself is useless, but it always gets you where the answer is, so you'll never make a mistake. I already know the answer is minus 1.4 something. That's why I know it has to stay between these two. That's why you should do graphical method, even if I don't ask for it in the exam, you should still do it because it almost gets you to the answer right away. Now do the next iteration. Next iteration will start with minus 1.5 and minus 1.25. What is minus f of minus 1.5? Minus 0.2525. What is f of minus 1.25? That's 0.3865. Is their product negative? Yes, of course. This is sort of like a sanity check. You keep doing this, you know that you are still on the right track. This doesn't give you any new information. Yes?
So if it's negative, you can change the root.
Yeah.
So you don't change the bounds.
Yeah.
It's positive, then you keep getting smaller.
It's sort of like saying, actually, I don't know how I missed this example. What sport do you like?
Sorry.
What sport do you like sport, like game, outdoor games? Like, do you play soccer, football, baseball? Soccer.
Yeah.
So if you are going to kick a certain distance, and if you know there's a goal or target, if you overshoot it, or if you undershoot it, what do? What does your brain do? It compensates with the amount of force you give, so that you know that you are, based on the feedback you get about where the ball lands, your brain compensates for the force. We are literally doing that. If your product is negative, if your root is contained in that root, in that interval, you either drop the left or drop the right, and squeeze it in. Squeeze it in. At one point, we'll get them to be so close, they are practically the same numbers, and then we stop. Okay. I like the example with Angry Birds. You adjust your force or your angle to hit the target, and you know how to compensate even without anybody teaching you. That's how the brain works, right? All right. Midpoint of 1.5 and 1.25 is what? 25 and 50. What's the midpoint? 37.5, right? That's the midpoint of 25 and 50, right? So minus 1.375. That's the next value of x naught. And I want to know what is the value of the function there, which is 0.0902. Positive, I think. You agree with me? 0.0902. Devote, right? That's your name. Devonte. Okay. Are you with us? Following? Good. Okay. So now get the product. Product of f of a and f of x naught is negative. Negative. It's between minus 1.5 and minus 1.375. So this is negative, and the other between f of b and f of x naught, it's positive. So now you tell me what is the new a naught? or new A star. This still contains the root. What does that mean? A to x naught still contains the root. What does that mean? It means the left point remains the same, which is still A, which is still minus 1.5, but the right point is now replaced with x naught, which is now minus 1.375. What is our answer? Which we got from the graphical method? 1.4. So we are getting close. We are getting between 1.5 and 1.375. So it's getting near. Okay. All right. Okay. Now answer some questions for me. How long do we do this? Until end of class? Until end of the term? How long should we keep on doing this? Not fun, you know. Okay, you tell me when to start. That's the question.
Happy without specific,
Define happy.
I guess whenever your employer is happy,
It's not all about jobs and money.
You're happy.
Okay, can I get wait? Am I in a school of philosophy or something? Is this an engineering class? Can I get some quantitative measures?
so as close to the number you got with the graph.
10. You are saying 10. You are saying closest to the graphical method. Do you have anything to say? No. So you are not on the like 10th doesn't mean anything. If you are, it depends on your application. So do you think having something down to the 10th of a decimal point is accurate enough? Well, it depends on the application. Suppose your job is to align a mirror with a laser source or align your laser with a mirror that is kept on the moon. You make instead of setting it at 10 degrees, you do 9.9 over a million miles. That's a huge distance. So it has a very real consequence, just even though it sounds like a 10. So in that case, if you're doing this, the angle or the tolerance you want is dictated by the distance you can tolerate. So just to make a point that arbitrarily saying a tenth or 100 doesn't make sense. What you said is get as close to possible as the graphical answer. That's what you said, right? That is still also not quite right. It's better than what you said, but the graphical answer itself is approximate. We said minus 1.4, right? But we didn't even know if that is the best answer we could get. We could keep on doing more accurate answers there also. So that also is not a good way to stop. What else can we do to come up with a rational stopping criterion of when to stop doing these items? You are getting this range, right? Ultimately, you start with AB and you are bringing them closer and closer and closer and closer, and then you are finally ending up with the root. When you have done enough iterations, you get A and B to be practically same. Like for example, it's like saying A is minus 1.501 and B is minus 1. A is minus 1.401 and minus 1.399. Suppose this is your A and this is your B. Technically speaking, your root still lies between the two, but it's almost like saying it is minus 1.400. When your A and B don't differ much, and much is a very subjective word, when your A and B are same to the level of accuracy that you are seeking, we can stop. Or in other words, if I write A minus B divided by A, if I express that as a percentage, I'm going to pick the criterion. If this drops below 0.1%, good enough for me, I'll stop.
So in the exam, will you tell us how many iterations to do for?
I'll either say number of iterations or I'll give you a criterion like this. I'll say keep iterating until they fall within 1% of each other or 0.1% of each other or something. But in the exam, I typically design it to be no more than like four iterations. If I can't figure out you have understood something in 4 iterations, 2 more won't help me. 4 is what I aim. So what is the percentage difference between these two? How many percent are they off from each other? How do you compute that? 1.5. How much this as a ratio? How much is this as a ratio? This is 12.5 points, 12.5 parts over 150 parts. Right? How much is that?
0.0834.
0.0833 as a ratio, but as a percentage, that is 8.3%. If I'm giving you the stopping criterion, they should get within 1% of each other. You are now at 8.3. If you went back and computed the difference previously, they would be even larger percentage from each other. So you have to do one more iteration, check again. Has this dropped below 1%? No. Keep continuing. Has this dropped? No. Keep continuing. Has this dropped? Yes. Stop. That's how you put this thinking as an algorithm. From the looks on your faces, either I'm doing very well or very bad. This, okay? Because yeah, some of you are like, your focus probably, I'm not getting any response, so it's hard to judge how this is going. All right, so we are at 8.3% now. So I'm going to add one more column here, the last column. The last column, which is percentage difference between A and B. Percentage difference between A and B. So I can just take the two values, X naught and B, and compute the difference. So you can take X naught, which is this 1.5, and B, whatever is here, A and X naught, A and X naught, compute the difference. The last one I computed, which is 12.5 divided by 150 or 8.3%. Keep iterating until difference falls below 1%. I'm setting that 1% criterion. In your problem or application, it might be something else. Okay. If you promise to me that you got this so far, or if you tell me if you got this so far, instead of doing more iterations by hand, we can switch to Excel and build this as an Excel sheet, which can automate the whole thing. Okay. You all about the jobs and your what is it? Margins. Automation is everything. Okay, figure that out.
Efficiency.
Efficiency. So I listened to one YouTube video where some MIT professor said, if you can articulate a problem, it means it can be turned into an algorithm, which means it will be automated, and eventually that job will be gone. People are already automating flipping burgers, fast food, lot of automation taking place in many sectors. People want to AI to look at patients for visual symptoms that can be easily diagnosed, like pink eye, some like that. So many fields are actually becoming automated. Things that you thought are never going to be automated. I'm worried for my job. The day they figure out how to make a robot do all this, I don't know what will happen. Long time. All right. Okay, so I'm going to, are you done writing? Can I bring the screen? Yes, okay. You done taking pictures? All right. So just to note, our function, okay, our function f of x is 1 minus x squared minus sine of x, just to refresh our memory, okay? You have this in your notebook, right? So you can tell me what the columns are, in what sequence to build the columns. What is the first column? A, B, f of A, f of B, x naught, which is a plus b over 2, the midpoint, and then f of x naught. Simple enough, right? You go to the folder I shared of previous year course materials, you can find many Excel files for bisection method, Newton-Raphson method, all the things that we'll talk about. I've done this couple of times before. So you can find those files, use them as a starting. You don't have to do everything from scratch. Okay. All right, what is A? Minus 2. What is B? 0. That's what we figured from our graphical method. What is f of A? You just need to punch in 1 minus a squared minus sine of A. You need to punch in that formula, press enter, and that's the beauty or convenience of the computer, which gives you the number. What is f of B? Just copy this formula, paste it one cell to the right. With me so far? Yes? Okay. What is your name? Evan? You're okay? Okay. Midpoint is simply A. Midpoint is A plus B divided by 2. Don't do your calculation yourself. Make Excel do it for you. That's the idea of this exercise. Type C5 plus D5 divided by 2, like I've done here. What is f of x naught? That is going to be 1 minus x naught squared minus sine of x naught. Give you an incentive. You guys get good at programming or using Excel and MATLAB, I'll let you keep your computer for your exams. So that whatever problem I ask, you can use a code to do it for you. But I'll still make it tricky, but at least it will speed up things if you get good at this. Okay, what's the next step? We had one step here where we computed f of A times f of B, which is the product of these two. Okay, and then we compute what is f of A times f of x naught. Somebody was getting ready to speak. I interrupted. You want to say something? No? How will you do this? F of A times f of x naught. Can you tell in terms of the columns here? This J. How do you write J? J5 is E5 times I5. E5 times I5. E5 times I5. And then f of B or f of x naught times f of B is f of x naught is I5 times f of b is fy. Following so far? Yes. What is the next step in words? Tell me in words, what do we do next? If this is negative, what does that mean in words?
That's the root.
Of course, it has a root, but what action do you take based on that information?
Keep the balance same.
Keep the left same, make the right, make the center the new right. Okay? How do you put that into a statement? So if I say new A, how do you turn that into a statement? If this is negative, that is your condition. If this is negative, if this is negative, if this column, please pause what you're doing, look up. This is a very important step. If this product of f of a and f of x naught is negative, then what is a? A remains the previous left, right? A is simply the previous left, which you can just go to your left and say this is A. If J5 is, look here, if J5 is less than 0, then that cell takes the value of C5. If not, it takes the value of the new X naught. Okay? If not, it takes the value of new X naught. If J5 is less than 0, wait. If J5 is less than 0, then it takes the value of C5. If not, it takes the value of H5. So new A is -2. Just look at your notebook. It's consistent with what we did. What is new B? Can you do it and then look up? Do it yourself. Are you able to do new B yourself? Yes, no? It's what? Sorry.
It's similar.
Similar to new A, but how do you implement it? So you can you tell me what is appearing in this line? What is on your computer? You tell me, and I'll say if that is correct.
Uh,
If
it,
which column? Well, look up and tell me from my sheet which column. This is M5. I can't check M5. I'll have to check something to the left of M5. Are you implying K5? No?
the reading of the and all match screen.
That is you are just entering the value of B directly. What I want you to do is put a if statement and the computer should decide it, not us. We shouldn't be entering B is equal to old B. Does that make sense? Anyone else? K5, yep. If K5 is less than 0, that is if this number happens to be 0, what does that mean? It means x naught to b contains the root, right? Which means b would still remain the same, a would come forward. You've already figured out a, forget about a, just think about b. If this number is negative, b remains the same. If this number is positive, the center becomes the new right. Right? So if K5 is less than 0, then new B is simply the old B. And if it is otherwise, that is, it can either be negative or positive. If statement has only two outcomes, either positive, either yes or no, right? Otherwise, it becomes X naught. Otherwise, it becomes X naught. That is the first iteration. Okay, so I will call this iteration number. This is 1. Second iteration, all I'm going to do is at the end of the first iteration, I computed A. At the end of the first iteration, I computed B. I'm just going to say, I bring them down. Literally what I did on the whiteboard where I wrote this from the last line there. So I'm doing A and B have now changed to -2 and -1. Same thing we did when we did by hand. Yes.
Yeah, I got it.
Okay. Then for the next line, what do? Do you still type everything up? Do you need to? That's what Excel is for, right? Just copy the previous line and drag it down. So in 1 second, we are able to do one iteration now. Speed. So you have this f of a, f of b, everything is figured out. You can go to the right and find out where your new a and new b are and check with your hand calculation. Okay, good. Now, what is the difference between A and B? Difference between A and B as a percentage. That would be A minus B divided by A. And I'm going to express this as a percentage. 50%. First iteration, they differ from each other by 50%. Not ready to meet my criterion of 1%. The next iteration, 33%. Still too large. Can you do 4 more iterations if you have gotten up to here? If you have 2 iterations locked in, can you do 3, 4, and 5 and 6? Is this checking with you? I would, even if it's imperfect, I would try now than sitting back and thinking I'll figure it out later by myself. And that's what I'm here for. Not clear, ask me. Okay. So we left it at third iteration, fourth iteration. For one moment, look up, see some, make some observation. You started with a range which you got from your graphical method by just crude inspection, -2 to 0. And as the iterations went on, you kept squeezing them together, where at one point you know that the root is between 1.42 and 1.41. This is, if you round it off to 2 decimal points, this is 1.42, this is 1.41. Okay, you can go further. That is, you can add more iterations here, 9, 10, 11, 12, and you can see how close A and B actually get. That is the whole exercise of finding a root, which is to say, at one point, it is between 41, 410, and 409. So if you round it off to 2 decimal points, they are practically same. Or if you wanted more precision, if you want, let's say, 4 decimal points, what do you have to do? If you want more precision, in this class, always the answer is do more iterations. Okay, you can add more iterations, and since this is Excel, it can take 40 iterations for all you care. It's not your hand calculation. So you can add more to get very precise answer. So let's say I want the answer to 4 decimal points. I want the first 4 decimal points to be the same for both A and B. I'll add more iterations. I'll keep dragging this down until they are practically same. So I'm getting 409624 or 409624 and 409623. They are only differing in the 6th decimal point. I'll do it to a 10. And that's a fine approach, but in just case you are interested in doing it to a 10,000, this is how you would do it. So that you can say to the first 4 decimal points or down to the 1/10,000s, they are practically same, and then they might have more fluctuations after that. Shall we do one of the homework problems using this template? Okay, so I want you to so in the homework, I've given solve problems 5.4, 5.5, 6, 7 using graphical and bisection method. Use Excel or any language. Let's see what those problems are. Uh, problem, let's say we pick problem 5.4. This polynomial is our function. You'll need to first do a graph of this and then use the bisection method. How will you start? Like, what should I do next? Instruct me, please. 5.4. Determine the roots of this function. Or if you like, we can do the other problems also. It doesn't matter. There, we can try this sin x equal to x squared, which is sort of non-linear. What should I do next? Or what's the first step? We are solving a nonlinear equation using bisection method or the other methods we'll see in the next lecture. Repeat after me. Always the first step is do a graph of the function and identify where the roots are. If you are going to solve for sin x equal to x squared, graph sin x and graph x squared to see the intersection, literally like we did before. Okay, so I go back to my graphical method. Okay, I wrote my function is 1 minus x squared equal to sin x. Well, this problem isn't very different from what we did. All you have to do is just write x squared equal to sine. Okay. Are you doing, or I mean, people are doing different things, so I'm not sure. Should I do this by myself, or should I do this in front of you, or you got this? What's the feel in the room? Shall I try? Okay. All right. So I'm going to make a copy of this, move it to the end. All right. So my equation is x squared equal to sine x. This is problem 5.5. Problem 5.5. All right. So we'll try to plot this function again from -5 to +5, and we'll use a step length of 0.1. And remember that your graphical method is supposed to be like a quick first order estimate. You don't have to make it super precise. You don't have to make it super precise. Okay. So you selected your interval, you generated the x values. We have to modify this. This is no longer 1 minus x squared. This is x squared. Y1 equal to x squared, which is x raised to the power 2, and I drag it down. Okay. Right hand side coincidentally remains the same, sine x, so I can just leave it like that. And I also computed the distance between the two as the absolute value of left side minus right side, and I keep it here. Together so far? Yes. What's the next step? What should I do next? I know you are saying it, say it loudly. Plot them, right? Say it loudly. Okay. Oops. Try a different type of graph. Okay, so here's my function. The parabola y equal to x squared and the function y equal to sine x. I plotted those two. Where can the roots be? Just by inspection. It clearly is somewhere between -2 to +2, right? It's not to the left of -2 or to the right of 2. Can you say that by inspection? Right? So I'm going to zoom in just for us to look at the roots. Okay. I can count 2 points at which these two curves intersect each other. At least 2 roots are found here, are to be found. Okay. So I'm going to start with -2 to something like 0.5, and then 0.5 to 2 as my two ranges. I have to find 2 roots. Be clear about that. There are 2 roots to be found. So in the exam, when it says solve for x squared equal to sine x in the range of -5 to +5, you are first required to check how many roots are there and then find all of them. If there are 3 or 2 or 1, you have to find all of them. So we'll do this exercise twice, one to locate the first root and then to locate the second. Are we together so far? Right? So first root is between, let's say, minus, in fact, if you are good at eyeballing this, you know that it's not even -2, it's literally actually between -1 and 0.5. If you make a very good initial guess for the range, you can save on iterations. Right? So let's say we do between -1 and some like 0.5. Let's see where that takes us. So I'm going to say bisection, copy this, move it to the end. This is bisection problem 5.5. I have only 5 minutes left. We'll see graphical problem 5.5. All right, bisection. Here's my function 1 minus x or x squared minus sine x. You tell me what of this should be changed and what of this we don't have to touch. Yes? You have to change a and b. That is our initial guess. What did we decide? We decide to locate the first root. We'll use a equal to -1 and b equal to 0.5. -1, 0.5. What else do we need to change? You're computing functions so many times, right? This was written for the old function, whatever was the previous function we did. Now our function has changed. You need to fix that. So you need to write this is x squared minus sine x. You just have to update the cells where the functions appear. Okay. And the rest of the method is actually, you don't have to touch anything. Literally, you don't have to touch anything. Once I updated that, how many times do we compute the function within one iteration? We compute f of a, we compute f of b, we compute f of x naught. 3 times. Except those 3 times, all other calculations are generic to the method. They don't depend on the actual function. Okay. So then you just have to have this, drag it down to how many ever rows you want. What's the problem here? Oh no, that's a problem. So you just have to, copy, drag this down. Okay, so this is interesting. Where is this headed? After 22 iterations, you get a equal to minus 2.2 into 10 power minus 7 and 4 into 10 power minus 7. Where is this going? If you look at this function, x squared minus sine x, 0 is a root, isn't it? 0 satisfies the equation. Your iterations are kind of becoming smaller and smaller, like 10 power minus 7 minus 10 power minus 7 plus. They are kind of squeezing in on 0. You can do more iterations. Eventually, you will get a 0 down to the level of round off in this Excel software. What about the other root? What about the other root? Can we say the other root lies between, let's say, between 0.1 to 2, 0.1 as the left end, and maybe even like 1.5 as the other end? Is that acceptable to you to find the other root? So I'm just going to write here to locate the second root. We set a equal to 0.1 and b equal to 1.5. All you have to do is go to your sheet, set a equal to 0.1, b equal to 1.5, and you get the root. You get this 0.8767 down to for 4 decimal points. That's your root. So if you have a well thought out Excel algorithm for your bisection method locked in, you can do your homework in 10 minutes. Because you just punch it in once, Excel will tell you the steps. All you have to do is copy it on paper, turn it in. Except don't turn it in, I don't want you to. Okay? So we're almost out of time. Next lecture, we are going to see what is called as Newton-Raphson method, which is also another important method. So there are 4 techniques in this unit that I will cover: bisection, Newton-Raphson, and 2 other methods. The 2 other methods, you are going to just look at them by yourself, like self-study, but I'll give you an Excel sheet which already has it implemented. So you will be able to look at it and teach yourself. Okay? Go through my materials that I posted. It will help you. There are lots and lots of examples for you to try. Okay? Thank you.